Children, now we are going to continue the session that was in first session. We are going to continue, and then after sir will decide which topic he is going to teach. Okay. So once again, we are welcoming our sir, Mr. V. Mohanram, and I hope this session is also going to be more fulfilling. Welcome, sir.
Shall we start? Yes. So actually, according to the portion or the coverage of the given to me is progression as well as binomial theorem and the logarithmic series, exponential and logarithmic. So morning I think we discussed only AP, GP, arithmetic progression, geometric progression. Okay, and the problems whatever I discussed are as I said as morning class has said I think based on our more level of problems, basic level. Where I think you have to think, then you have to solve. Okay, we'll take one or two problems once again based on that, which is a combination of trigonometric involved, logarithms involved, okay, and use your algebra, that is your sequence series and arithmetic progression and geometric progression. MCQ level, okay, not lengthy one. Then we will pass on to your binomial theorem part. Okay. First one or two problems you do, because after lunch I don't know how you people will feel. So one or two problems you just think, then start doing, then we will go with the new topic. Okay. Problem like this. Hope the last benches are able to see my letters and other things, because I am used with only a way of writing. Immediately I cannot change to a bigger one. Yeah, it's not audible. Hello. Yeah. Okay. It's okay. So, okay, two big problems. If ABC belongs to, once again, just 10 minutes, you think and you give me the answer. Okay, once again, MCQ, options will be given. I'll give the hint, just you give me the answer. A, B, C belongs to R plus, then the minimum value of the minimum value of the minimum value of B plus C by A plus C plus A by B plus A plus B by C. So we have four options, something like so the minimum value minimum. So the value should be the minimum value is just say use once again the inequality. Arithmetic mean is greater than or equal to geometric mean. The hint for the problem is you take 6 numbers. How the numbers are means B by A, C by A. Okay, got it now. What the numbers I am saying. Next number will be C by B, A by B, A by C, B by C. How many numbers now we have? 6. For that 6 numbers, you apply your A and G. So remember, what we discussed is nothing but a particular case. Morning I said, two numbers arithmetic means I said A plus B by 2 is greater than or equal to 2A. Alright, two numbers. When you have 3 numbers, my condition will be A plus C plus A plus B plus C by 3 is greater than or equal to cube root of ABC. Remember, for two numbers, A plus B plus A plus B by 2 is greater than or equal to this will be what? AB the whole power half. When you have 3 numbers, it should be ABC the whole power 1 by 3. When you take n numbers like A1 plus A2 plus etc. up to An by n will be greater than or equal to the product power 1 by n. Power should be 1. This is the logic. This is a particular case what we discussed in the morning session. So you generalize it. Okay.
Option 4, 6.
Option 4. Yeah, because that's the hint I have given to you. Okay. So anyway, answer will be 6. The minimum value. The minimum value, because if I write the numbers like B by A plus C by A plus C by B plus A by B plus A by C plus B by C, whole thing by 6. All these things is greater than or equal to the product B by A, C by A, C by B, A by B, A by C, B by C, the whole part 1 by 6, because we are having 6th root. See the generalization, okay? But all the terms get cancel here. You will get 1 part 1 by 6, 1. This number 6 will come here. Therefore, this summation is greater than or is equal to 6. So it should be 6 and above. So the least value, the minimum value will be equal to 6. So that is the solution. So once again I repeat, this is a particular case because usually A and B means we used to think of only 2 numbers, sometimes 3. If we have more numbers, the rule is nothing but this particular. Okay. This is one. Next one. Find the minimum value of 4 plus 9 x squared into sin square x, a trigonometrical part, but we won't use any trigonometry, by x into sin x. But x is between 0 and 180 degrees. It is a pi radian. Anyway, don't bother about the condition given. You just find the value of minimum value. Once again, find the minimum value of 4 plus 9x squared sin squared x by x sin x. Criteria is the same. AM is greater than or equal to GM criteria used. Every problem you are supposed to think of 2 numbers, 2 or 3 numbers. Previous case I said you have 6 numbers because when you divide, then only you will have that particular idea. Now what you do is split the problem into 2 numbers. Yeah. Answer is 4. Anyway, I can give the MCQ. Okay, 4. Anyone? How can you say how you got?
I actually wanted to just understand this correction first.
Okay.
And then I have tried to take the LCM relation.
Is it 4 you are getting or some other number? Let's check it once. Okay. You just divide by x sin x. What is it is? Can I write this as 4 by x sin x plus when you divide this by this, on x and sin x get cancelled, what I will get is, alright, 9x sin x. You got it? This by this by this. Is it one number A? Is it one number B? Isn't it? So now, A plus B by 2. Alright?
12.
Yeah, A plus B by 2, 4 by x sin x plus 9x sin x divided by 2 is greater than or equal to square root of 4 by x sin x into 9x sin x. No trigonometry here. So your x sin x get cancel. 9 into 4, 36. Root 36, 6. This number 2 will come. So 4 by x sin x plus 9x sin x value will be greater than or equal to 12. So my minimum value is 12. Okay, equal to my minimum value is 12. So only thing you should identify. Once again, as I said, we won't get directly a trigonometric problem here, but the problem involved. And once again, the hint for such type of questions is you are not asked to find the value, find the minimum, find the maximum. In such cases, inequality is required. So obviously, think of AM as well as GM criteria to get your answer. Okay, good. Please, students got the answer. We'll go for one more, the last one. If x and y belongs to R plus, comma, x plus y is 8, x plus y is 8, find the minimum value of, find the minimum value of 1 plus x, 1 plus 1 by x into 1 plus 1 by 1. I'll give a hint for the problem. Take this part, purely you simplify. That means your ordinary multiplication, you multiply and write the terms. After writing the terms, apply your AM greater than or equal to G. Okay, I'll give a minute. At least half minute if you do, I'll be happy. First you simplify the term 1 plus 1 by x into 1 plus 1 by y. Totally you simplify. Then just you think of the previous problem procedure and get the answer. If you simplify the total, 1 plus 1 by x into 1 plus 1 by y, what will you get? Should be x plus 1 into y plus 1 divided by zxy, which is nothing but xy plus x plus y plus 1 y. Xy 10. After this is okay, but you have the hypothesis. What about x plus y? X plus y value is what? 8. For that you substitute here. So what I will get is 8 plus 1, 9 plus xy, y, xy. Now something like your previous problem, something 4 plus sin x, something divided. Split into two parts. Can I write this as 9 by xy plus 1? So now you have, if you know the value of xy, then I will get the value for this particular part. So I should find the value for xy down. Once again, use the condition of for x and y belongs to R plus, Can I write x plus y by 2 is greater than or equal to root x by 1 by? No. I'll proceed. Just see the process. After this is one stage. Then I started with the given condition and apply your an and gn inequality for this. Once again use this x plus y value as 8. So what did I get? 8 by 2, that is 4. Greater than or equal to xy. Square it. 16 is greater than or equal to xy. So I got the value for xy is less than or equal to 16. Xy is greater than 16 is greater than or equal to xy. Remember, when you take the reciprocal, you know that inequality sign will change. When you take the reciprocal, inequality sign will change. So I will write 1 by 16 is less than or equal to 1 by xy. That means we have xy here. So that means this value as it is, this 9 as it is, 1 by xy value, this is less than or equal to this, 1 by xy value will be greater than or equal to 1 by 16, isn't it? That means this will be greater than or equal to 1 by xy value is how much? 16, 1 by 16. 16 plus 9, 25. So my answer will be 25 by 16. This total is greater than or equal to 25 by 16. Then what is the minimum value? 25 by 16. So we use that x plus y value twice while simplifying this part and once again doing your AM and GM criteria. Okay, give us a someone said the answer 4 or something. One here. Any different answer? Think here. Procedure. Okay. We have one problem. Are you okay? Between 1 and 31, between 1 and 31, between 1 and 31, M arithmetic means are inserted. M arithmetic means are inserted so that the ratio of the 7 and m minus 1 means, that is arithmetic means, 7 and m minus 1 arithmetic means are in the ratio 5:9. Are in the ratio 5:9. Find the value of m. Find the value of m. I think as we discussed in the morning about arithmetic mean, suppose if you have the arithmetic mean, n arithmetic mean between A and B, the common difference is given by the formula b minus a divided by n plus 1. So
Morning I started with one problem. 4 arithmetic mean between 1 and 11. Okay, remember that part. Okay, I take once again the same. You have 4 arithmetic mean between 1 and 11. If you remember, we got the common difference as 2. You just observe, if I substitute here, this is A, this is B. So what I will get? 11 minus 1, 10 by, how many arithmetic mean is it? 4. 4 plus 1, 5. 10 by 5, 2. So you have a direct formula where you can calculate the common difference in arithmetic means. So your common difference in n arithmetic mean between A and B is B equal to B minus A by n plus 1. This is the formula. Now how many arithmetic means are there? You are having
14. 14.
40. The value for m here.
Like, put it at 14.
40. For this. You are saying for the value for m? You are saying value for m? No. Value. Yeah. Okay. Okay. What the method you are using? Now first, shall we get the value for d? Number of arithmetic means we won't find the arithmetic means. We'll find only d. So your d value is nothing but d minus a divided by m plus 1. But the numbers are 1 and 31. This is 1, this is 31. So what I will get? 31 minus 1 by m plus 1. So my answer will be 30 divided by m plus 1. I don't know what is m. That only you are supposed to find. So the common difference for all the m arithmetic means will be 30 divided by m plus 1. Now, ratio of the arithmetic means, it is not the term. Right, understand? It is not a term. Once again, I will start like this. First term, A1, A2, A3, A4 and 11. Once again, for just to refresh you, I am writing the term. This generally remains as the first term. What about the second term in general? We will write as A plus B. Alright, this will be A plus 2B. That means in the second arithmetic mean will be in the general form A plus 2D. Fourth arithmetic mean will be in the general form A plus 4D. The final one will be A plus 5D. Using this only, A is known, this is known, I get the value for D as 2. Now, what I need is the seventh arithmetic mean. Seventh arithmetic mean means I should write that as what? A plus 7D. Okay, it is not A plus 7 minus 1 into D. So the ratio of seventh arithmetic mean will be A plus 7 times B. What is A? A value is 1. What is B? B value is 30 by m plus 30 by m plus 1. That is B value. So substitute here 1 plus 7 times 30 by m plus 1. Just because eliminate all A, B, you have to get only the term as m. Now take LCM, what I will get? M plus 1 plus 210 divided by m plus 1. What I will get is 211 plus m by m plus 1. This is my seventh arithmetic mean value. Don't bother about the larger number. Okay. Now what is number? M minus 1 the arithmetic mean. So m minus 1 arithmetic mean is given by the formula a plus m minus 1 into d. Now once again for d, we substitute this particular value. So what I will get? A plus m minus 1 into d is 30 by m plus 1. Once again, so a value is nothing but once again 1. So by taking LCM, it should be m plus 1 plus is it 30m, am I right? Minus 30 divided by m plus 1. Value. Now if I simplify, here m, here 30m, so I get 31m, then 1 minus 20, 30 minus 29 by m plus 1. Just see the numbers. This is 7th arithmetic mean value. Check my calculation once. This is my m minus 1, the arithmetic mean value. These two are in ratio what? 5:9. So at least now, can I have the answer? That means 211 plus m by m plus 1 by 31m minus 29 by m plus 1. The ratio will be 5/9. The ratio will be 5/9. Now, can I have the answer please now? Does m plus 1 get cancelled? And value will be 14. So if I simplify this, these two get cancelled. I will get the value for m is equal to 14. In this you can. It's a simplification. Yeah. Pardon? So 14. I got it. 14. That's why I repeatedly asked. Okay. So how? You got? Ratio. So ultimately B is it will cancel? So B is equal to 2. But here the even you can write the common difference, but you don't know what is the value for m. If the d value is somewhat fixed, because I have m arithmetic means, once if you know how many exactly n arithmetic means are there, then only I think you will get a d term as a constant term. Yeah. So without calculating the, I think we will be able to. So D is nothing but generally I got the answer as 30 divided by m plus 1. Now if I substitute m is equal to 14 here, whatever value you are getting for D, that is justified. Alright? That's the way. But without calculating the D exactly as a 2 in the beginning, you just get the value for m. Because initially the value of D is expressed only in terms of 2 plus 1, not as a constant. And the ratio you are calculating for the arithmetic means, not for the terms of area. Isn't it? So when you have the ratios of the arithmetic means, I think this is unknown quantity as it is in terms of m. So your option answer is right, okay, but the process is nothing but there. Okay. This one purely a numerical problem about this. Out of this, we'll see. It is a problem from purely a geometric progression. Okay. A rule, right? A rule given by f of x plus y. A rule given by f of x plus y equal to fx into fy for every x comma y belongs to natural number. For every x and y belongs to natural number, and f of 1 is equal to 3. F of 1 equal to 3, and sigma fx, where x varies from 1 to n, is equal to some number 120. Sigma stands for summation of n numbers with this particular rule. The answer is 120. The question is find the possible value of n.
4.
Equal to
4.
yeah, any other answer? So the rule is nothing but f of x plus y is equal to f of x into f of y. The condition is f of 1 is 3, and summation of f of x from 1 to n, x varies from 1 to n is 120. And what will be the value for? Yeah. is that n equal to 4? Can you have the explanation?
So actually, this f of x plus y equal to f of x into f of y is a general format for the exponent. For example, some number to the power x. So we can see that if f of 1 is 3, then we can take 3 to the power 1. And I'll try and add 3 power 1, 3 power 2, 3 power 3, 3 power 4, where it will arrive at 20. It arrives at 4, n equal to 4. That's it.
So ultimately, the series of numbers or sequence of numbers what you are going to get is in nothing but in GP. Exactly. Very good. So that is in terms of exponents. Okay. Now, how he got the number 3? Then he said 3 squared. Then 3 cubed. That's the terms he said, isn't it? The process is this is the rule given. So f of 1 is given as 3. So you start with, and numbers are natural numbers. F of 1 plus 1. I'll start with, actually it is f of 2, isn't it? F of 2. F of 2 is nothing but, this is 3, this is 3, so I will have 9. F of 1, which is given as what? 3. So if I go for f of 3, I will write f of 2 plus 1, that is f of 2 into f of 1. So 9 into 3, 27. That only is an exponential. So first number is 3, second number is 9, next number 27, and it goes on. So but summation is equal to how much? 120. The summation equal to 120. That is 3 plus 9 plus 27 etc. up to n terms. The value is given as 120. We did use the formula so for GP, isn't it? So GP formula. So here first term 3. What is the common ratio? Common ratio is also 3. So I can use the formula Sn is equal to A into, am I right? R power n minus 1 by R minus 1. Something in terms of the GP. So if I use here, A is 3, R is 3, minus 1 by 3 minus 1, that is equal to 120. This 2 will come here, 240. This 3 and 240 get cancel. 3 power n minus 1, so 80. This one will come here. So 3 power n equal to 81. So the value for n is equal to 4. So that's why in the beginning itself I said the problem is in geometric progression. So only thing we should identify the process. So as we said, it is an exponential part. The number will increase. So apply that and you will have immediately result. Okay. Up to that, AP, GP, AM, GM, and some inequality problems, and some problems based on GP. If you have any doubt, maybe for 2 minutes, you can ask. Then I will go for your binomial theorem part. Okay. Yes. Shall we proceed? Okay. Okay. So what do you mean by a binomial theorem? So everyone knows the basic identity in algebra, starting with a plus b the whole square. Whenever we write, we will write like this. Okay, and even morning I wrote a plus b the whole cube. Am I right? So anyway, so now you are having two terms, maybe a and b. The power is nothing but a natural number. The power is nothing but a natural number. If you are asked to expand a plus b the whole cube, a plus b the whole square, I think it will do. Suppose my question is expand a plus b the whole power 10 A plus B the whole power 20. Power is a natural number. Once again, okay. In that case, how to write the expansion? How to write the expansion? So now I will discuss maximum with power 5 or 6. For that, I will give one particular rule. This part you will study in combinations and permutations and combinations. Okay, we call one type of triangle as a Pascal's triangle. Once if you know that pattern, once if you know that particular pattern, I think these numbers you can write. These numbers you can write, only numbers. Afterwards, I will tell you how to write the terms. Okay. The Pascal's triangle starts with the number 1. Okay. Then once again, 1 and 1. So this is the index. Index means power as 0. That is, if I put power as 0, anything power 0 is 1. When I put power as 1, it will be 1 into A plus 1 into B. So that is a coefficient. Then once again you start with 1, add these two right in the middle. Once again you end with 1. Now just see, these are the coefficients of these terms, A square, AB and B square. Extend this logic, 1, 1 plus 2, 3, 2 plus 1, 3, once again 1. These are the coefficients of A plus B in the whole cube. So once again 1, then 4, then 6, then 4, then 1. So once if I have this, it will go as it is for natural number. It forms a triangle and we call it as a Pascal's triangle. I write maximum 5. So here 1, 5, 10, 10, 5, 1. Now what I need is A plus B the whole power 5 I need. So when I need A plus B the whole power 5, the speciality of these expansions, if you see, what is the power? 2, you will have number of terms is 3. When the power is 3, the number of terms is 4. So based on this power, it will have one extra term, one more extra term. So when I have 5, the total number of terms I should get as 6. Once if you know this part, you can write your expansion. You can write your expansion. Then do. Once again, you see the speciality of the terms. I'm saying terms. Starting with A cube, the power of A is in decreases. At the same time, the power of B increases. So that the degree, if you see, here actually it is B power 0. Here I can write this as A power 0. If you see the degree here, degree always remains the same as this number. Here degree is 3 plus 0. Here it is 2 plus 1. 1 plus 2. 3 plus 0. So your degree remains the same. One variable power increases, one variable power decreases. So what you can do is first apply that logic for this. Start with A power 5. Because actually I should use otherwise the combination formula like NCR, NPR and other thing. That I'm not touching, just I'm saying this way. So start with A power 5, B power 0, gradually decrease this power, increase this power. Then I will have A power 4, B, then A cube, B square, A square, B cube, A, B power 4, finally B power 5, A power 0. And since it is plus, in between everywhere it will be plus. And now you see the Pascal's triangle that values for n equal to 5. These are the values. So if I take that, this is 1, this is 5, this is 10, this is 10, this is 5, and this is 1. So actually in your combination, we used to write this as NC0. It's a combination formula. NC0. NC0 is 1. And one more thing, if you see the pattern, first term and last term remains the same. Second term and last term remains the same. So the coefficients are equidistant from the beginning and the end. The coefficients are equidistant from the beginning and the end. We will have a like sign, all like sign, provided you have a plus. If we have a minus here, then we will have alternate in sum. Okay, so that is the rule for your a plus b the whole power 5. Actually, as I said, it is nc0. This I will write as nc1. This I will, sorry, phi c0. This I will write as phi c1. This I will write as phi c2, phi c3, phi c4, and this is phi c5. So actually, what I mean by that NCR 5C5 means you are having 5 items. You are supposed to select all the 5 items at a time. How many days you can do selection? Only once. You can select all the 5 items at a time. So that can be done in only one day. That is the meaning of your combination. Okay. So in general, we will say NCR stands for selection of R items out of N. Definitely R and N may be equal. Otherwise, R will be definitely less than N. You cannot select 10 items when you have only 5 items. So that's why R should be equal to N or R should be strictly less than N. So instead of using this particular part, okay, so we can write like this. So in general, so your binomial theorem for natural number, I can write x plus a the whole power n. The same logic. How many terms will be there? Here, how many terms are there? 6 terms. If it is 5, the total term should be 6. Here the power should be n. So I should have n plus 1 terms. So the same way, don't bother about the value now. I will write the first term as nc0. Now I have written here by c0, so we will write nc0. This power you start with the maximum, a power will be 0. The logic is one term power should increase, the other term power should decrease, so that the degree when you see it remains the same. We call it as a homogeneous expression. Homogeneous means degree everywhere remains the same. That is the meaning for that. So next one I will write nc1. X power will decrease to n minus 1 into a. Am I right? X power decreases, a power increases, and it goes on. One more term if I write x power n minus 2 into a squared, and it goes on up to last term 5c5. So it should be ncn x power 0 a power n. So if you able to understand this particular part, you generalize the expansion of x plus a the whole power n, where n belongs to natural number. N belongs to natural number. So this we call as the binomial theorem for natural number. So somewhere the process ends. Where the process ends. So this is your expansion. Okay. Now, while one or two simple problems we will do. Anyway, I need that part. To find the general term. We used to say always the general term in that particular expansion, we write the rule as PR plus 1. We call it as the general term. So, which is given by the formula NCR x power n minus r into a power r. So, we just check if I put r equal to 0, just carefully observe. If I put r equal to 0, I will get T1. T1 stands for my first term. If I put R as 0, I will get NC0, x power n, a power 0. Suppose if I put R equal to 1, okay, I will get 1 plus 1, 2, that is second term, that is NC1, x power n minus 1, a. So like arithmetic progression, how we used to remember the nth term is what? Nth term of a is a plus n minus 1 into d. The same way, the general term of your binomial theorem is taken as Tr plus 1 will be NCR into x power n minus r into a power r. So, whenever you want to do any expansion or to find some coefficient, I think we won't expand it. We will apply this particular rule, and whatever we need, that part we will simplify. So remember this term, the general term of your binomial theorem is given by the rule NCR into x power n minus r into a power r. Okay, and this is a general expansion of your binomial theorem. Okay. Now, one simple problem we'll take. Just to observe, suppose if I want some number I'll take, the whole power 7. This is my expansion. The question is not exact number. You are asked to find the coefficient of x power 5 in this expansion. That means if I write this one, I can say what is coefficient of AB? You know, coefficient of AB is what? 2. Am I right? What is coefficient of A squared B? 3. So this you have done the expansion and you are getting the answer. Now, you are not supposed to do the expansion. Use this one and see that is it possible to have the coefficient of x power 5 in the expansion or not. Okay. The rule is this. So instead of x I am having x squared. Instead of a I am having minus 1 by x cube. So because most of the problems in binomial theorem we'll use only this particular logic unless and otherwise if it is required to expand. So if I substitute here, can I write general term? What is n? What is n? N is 7. Instead of x I am having x squared. Instead of a I am having minus 1 by x cube. Substitute here 7 c r x value x squared the whole power n minus r. Instead of a you write minus 1 by x cube the whole power r. Remember you are supposed to find the value of r. And remember r is a positive number, starts from 0, 1 to integer. Okay. Now if I simplify 7cr, can I write this as x power? Alright, 14 minus 2r. Bring this to the numerator and you write this as minus 1 the whole power r into x power minus 3r. Now this 7cr minus 1 the whole power r you keep. This and this you combine. Base remains the same. Can I add the power? So what I will get? 14 minus 2r and 3r, 5r. Now, what you are asked to find? Coefficient of x power 5. That means this term should be equal to 5. Then what should be the value for r? Alright, the power should be 5. That means that index you equate to what number? 5. So 5 will come here. So 9 equal to 5r. So r is equal to 9 by 5. It is not applicable. R is 0, 1, 2, 3, 4 positive integers. R cannot be fraction. So r equal to 9 by 5. That means you won't get coefficient of x power 5 when you do the expansion of this particular part. When you expand this, definitely you won't get x power 5. Maybe some other number if I equate, maybe I will have the answer. Suppose if I need the coefficient of x power 9, in that case, suppose if I have here, can I take any other number, easy number? What number? 5r here, 3, 4. Can I take 4 here? If I take 4, 4 will come to this side. So 10 equal to 5r, r equal to 2. So in that case, if it is possible, you can find. So the ultimate thing is, don't expand. So without your expansion, you are supposed to get your solution, whether it is possible or not. And one more thing, the term independent of x. The term independent of x means the power should be 0. That means the term independent of x means you should get a constant term. So that means this power should be equated to what? 0 to get your answer. So whether you are asked to find the coefficient or whether you are asked to find the term independent of x, in both the cases, the process is same. Whatever you are asked, that should be equated to that particular part and get the value for r. Okay. Is it clear? That part? So that is binomial theorem for natural number part. Okay. We'll do one problem. Okay. Just we will see. It was getting the solution for this. Take this one. The second, a little bit calculation part. Okay, that's all. the second, third, and fourth terms, the second, third, and fourth terms in the expansion of x plus a the whole power n are 240, number 720, and 1080. Find x, a as well as a. It's a purely algebraic calculation part. Only the initial stage, I think you will have a binomial theorem criteria. Afterwards, algebraically you solve and get the answer. Anyway, I'll do just calculate as I said, it's like a little bit lengthy in the beginning stage. Remember, it's a general term given. You are provided with what are the terms given? Third, second, third, and fourth terms value are given. Second term value, third term value, fourth term value are given. So, shall we write the general form? What is general form? AR plus 1 is what? NCR x power n minus r into a power r. So carefully observe, maybe you can solve afterwards. Don't bother about this. I'll tell you how to simplify these values. Now, when I need the second term, I should put r equal to. I need the second term, then I should put r value as 1, isn't it? If I put r equal to 1, I will get t2. So what I will get? NC1, x power n minus 1, a power 1. But what is this value? This value equal to 240. Remember, only the first step is binomial. If I put r equal to 2, I will get the third term. So r equal to 2, if I put, I will get NC2, x power n minus 2, a squared, which is equal to 720. If I put r as 3, I will get the fourth term, that is NC3, x power n minus 3, a cube, that is 1080. That's all. Your binomial theorem part is over. So you have simplified and you got three equations in terms of x, a as well as n. Once again, listen. If you remember the Pascal's triangle, what I said, this one, this is 3c 0, this is 3c 1, this is 3c 2, this is 3c 3. I'll tell you how to calculate. Suppose if you want to calculate 10c4, directly I am going. If you want to calculate 10c4, don't bother about any new formula. What you do is, in the denominator you write 4 numbers starting from 1. So I should write what? 1 into 2 into 3 into 4. Numerator you write 4 numbers starting from 10 in decreasing order. So first number 10, then 9, then 8, then 7. For time being, this is the way you can calculate your what number? NC4. Are you able to get? Isn't it? So if I simplify this, I will have the solution. Okay. Can anyone have the answer for this? 8C2, how will you write? I didn't want the answer at least. 8C2, how will you write? 8 into 7 by 1 into 2. Simplify 56 by 2, what you will get is 28. Okay, got the process. Now, when I say NC1, NC1 is n. See here, 3C1 is 3. So NC1 is n. When I need NC2, can I write this way? Anyone? How will I write NC2? First number n, next number n minus 1 by 1 into 2. Am I clear? Because I need that. Then only it becomes purely an algebraic calculation. So what I will do is, I will substitute this here. What is NC1 now? N. This as it is x power n minus 1 a, that is 240. NC2. NC2 is n into n minus 1 by 1 into 2 x power n minus 2 a square, that is 720. What is NC3? How many numbers? N minus 1, n minus 2 by 1, 2, 3 x power n minus 3 into a cube, that is 1080. Now there is no combination formula, nothing. Now we have only algebra. Okay. Anyone? Can I have a method? I have how many unknown quantities? How many unknown quantities? 3. X, A and N. How many equations? 3 equations. So, only solve. Anyone? Any easy method?
We'll divide one by one.
We will divide. So, what we will do is 3 variable equations, we will reduce it to 2 variable by divide this 4 by 6, whatever way. 4 divided by 6, you do one equation. Now 5 divided by 6, you will get one more equation. In that, if you solve, I think you will get any one of the value. Okay. Suppose if I proceed like this, if I divide 4 by 5, 4 is 240 by 720. Just check my calculation. Equal to, when I divide this, n x power n minus 1 a by n into n minus 1 by 1 into 2 x power n minus 2 into a square. Now what I get? See here, n get cancel. Am I right? Yeah? You got it? Yes.
X is equal to 2, A is equal to 3 and N is equal to 2.
N equal to 5. Yeah. Any other method? Or it's as it is. Possibility. But hope the possibility should be exact, isn't it? Okay. It should be true. Maybe after getting, you just substitute the values there and see that you are getting not only for one equation, it should satisfy for all the 3 equations. Okay. Anyway, I will check your values once again. This n and n get cancelled. This x power n minus 1 get x power n minus 1 get cancelled. What you will have is x power minus 1 here. This a and a square, 1 a get cancelled. 240 and 720, if I cancel, it will be 1 divided by 3, 24 and 72. This 2 will come up, the numerator. And as I said, numerator you have 1x and denominator you have n minus 1 and 1a. Check this. This n and n get cancelled. X power n minus 1 here get cancelled. So here x power minus 1. That x power minus 1 I brought to numerator. This a and a square get cancelled. So you have 1a. And this 2 will come to numerator. And 240 and 720 I cancel. It is 1 by 3. So this is one more equation. The same way you do divided by 5 by 6. If I do 5 by 6, yeah, this is once again 720 divided by 1080 equal to n into n minus 1 by 1 into 2 x power n minus 2 a square by n minus 1 n minus 2 by 1 2 3 x power n minus 3 into a cube. The same way 72 and 108 you can cancel. Shall I cancel by what number? 36. 2 times 36 is 72 and 3 times 36 is 108. So it should be 2 by 3. N minus 1 get cancelled. This 2 get cancelled. 1 a squared get cancelled. X power n minus 2 get cancelled. So you have 1 x power minus 1. That will come to numerator as x. This 3 will come to numerator 3x. Left out is n minus 2 into 8. Now still after this is the process. Okay, number may be a smaller number here. Sometimes we may have a larger number this side, not exactly visible. Even now I have all the 3 variables, x, a as well as n. But whether you are having here x by 8, here also what? X by 8. Can I divide? Isn't it? So if I divide 7 by 8, what I will get is 1 by 3 by 2 by 3 equal to 2x by n minus 1 into a by 3x by n minus 2 into a. So x a get cancel. What I will get is 2 by 2 into n minus 2 by 3 into n minus 1. To be reciprocal, isn't it? Now this 3 get cancelled. 1 by 2 equal to 2n minus 4. I will see what answer we got. It is 3n minus 3. Cross multiply. 3n minus 3 is equal to 4n minus 8. This will be minus n. Minus 8 plus 3 minus 5. Yeah. N value is equal to 5. So once if we have the value for n as 5, if I substitute here or here, now it is two variable. You will get in terms of x and a. Once if you solve for x and a, you will get x value and a. Or substitute n equal to 5 here. Substitute n equal to 5 here and here. Simplify. You will get x value as well as a value. Anyway, I'll just proceed to confirm the exact value. Can I write 1 as n is 5. 5c1 x power 4 a, which is 240. Can anyone say what is 5c1? 5c1 is 5. So this 5 and 240 I will cancel. So x power 4 into a will be how many times? 5 and 240 means it will be 4 times. Is it 48? Alright, 5c1 is 5. 240 I can cancel. 4 into 5 20, I think 40, 48. And second equation, if I write n as 5, 5c2 x power 5 minus 2 into a squared equal to 720. 5c2 is 10. This 10 and 720 get cancelled. What I get is x cube a squared is equal to 72. Yeah. X value and a value. So, then n is already 5. After getting n equal to 5 only, you are getting this particular equation. Now, just you simplify. Write in terms of one variable. If I divide this, what I will get? If I divide x power 4 a by x cube a squared is 48 by 72. So I will get x by a is 48 by 72 means I think it is divisible by 12. Am I right? 4, 6, that is 2, 3. So x is equal to 2a by 3. Now I think you can check your value. This x equal to 2a by 3, if I substitute here, whatever it is, so 2a by 3, the whole power 4 into a is 48. 2 power 4, 16. A power 4, a power 5. 3 power 4 in the denominator is equal to 48. So, and we cancel 16 and 48 get cancelled. 3, a power 5 will be 3 power 4 into 3, it is 3 power 5. What is a? A power 5 equal to 3 power 5. The value of a is 3. If I substitute a equal to 3 here, 3 get cancelled. The value of x equal to. Suppose. You find the value of?
I found the value of n through Pascal.
How?
Like, you know that we are going to find the second row and fourth row is the element. So it means that either it is a row element or it is
Which are in the process. So even though the problem goes like this, the numbers are smaller number. Yeah. Yeah. It's a trial and error. Okay. Yeah, you can apply that, provide that. I started with the second, third, and fourth. Suppose my question is the three consecutive terms. Suppose three consecutive terms of the expansion is this much. In that case, you cannot take the number. Are able to get? Since the numbers are provided, what the logic you apply not always true. May be true for the numbers of the smaller number. If I say simply the consecutive three terms of the binomial expansion means I should take the term as r plus 1 and r plus 2. then only this process, this method, maybe the lengthy method, this process only will give you the solution for that. Okay, and that applicable by trial and error method because it has given a second term, third term, and fourth term. So you eliminated in Pascal's triangle only the first two columns. So third column onwards, I think you have applied even that trial and error. Am I right? Trial and error usually will not be always true. Sometimes it may be true. This is the procedure. So calculation part, I think you have to take that. Not more than that. Okay. Yes. And one more in binomial theorem part, we used to say the general binomial theorem is x plus a the whole power n. Sometimes we call it as a standard binomial theorem. That is the binomial theorem of the expansion for 1 plus x the whole power n. From here I am going to say two important properties which are very much important for solving next level problems. Now you write the expansion of 1 plus x the whole power n. I will use the general form. You just observe. We wrote nc0 x power n plus nc1 x power n minus 1 into a and so on ncn into a power n. Here your x is replaced by 1, a is replaced by x. So can I write this as nc0? Instead of x, it is 1. So my answer is 1. Next, nc1, 1 power anything into a. Instead of a, it is x. Next term will be nc2 x squared. And it goes on up to ncn into x power n. Just you observe, replacing your x by 1 and your a by x. What we will do is, instead of writing nc0, nc1, nc2, etc. up to ncn, we have a notation called c0. Okay, even morning sir said the syllabus, binomial coefficients. So the notation is, instead of writing nc0, you can write the term as c0 plus, can I write this as c1 into x, next term c2 into x squared and so on cn into x power n. This c0, c1, c2, etc. cn we call as binomial coefficients only when you have the expansion of the form 1 plus x the full power. It is not for x plus a the whole power. It is for 1 plus x the whole power. So these numbers we call it as binomial coefficients in the expansion of 1 plus x the whole power n. Now the two important properties. What I will do is I will just put x equal to 1 here. If I put x equal to 1, I will get 1 plus 1, 2. 2 power n. What about this side? Anyone? If I put x equal to 1, I will get first term c0, second term c1, then c2, etc. up to cn. So just now I said the property. That means the sum of the binomial coefficients is always equal to 2 power n. We need this while solving not only problems in binomial theorem, even in some other topics where your permutation and combination comes. So c0 plus c1 plus c2 plus etc. up to cn value will be equal to 2 power n. One more result, instead of x, you put x equal to minus 1. If I put x equal to minus 1, this particular side my answer will be 0. Am I right? What I will get here? C0. Next term. X equal to minus 1. So what I will get? Minus C1. So C0 minus C1 plus C2 minus C3. So I will get an alternative sign. C0 minus C1 plus C2 minus C3 and it goes on. Now we just observe. I will take all the positive numbers. C0, C2, C4, those values one side. These negative terms, you bring it to that side. So what I will get? C1 plus C3 plus C5 and so on is same as C0 plus C2 plus C4 plus etc. All positive. C0, C2, C4. All negative terms, you bring it to that side. That means, can I say these are the sum of the even terms of binomial coefficient? Isn't it? These are even terms, these are odd terms because C0 is the first term. C2 is nothing but the third term. So this is sum of odd terms of binomial coefficient and this is sum of even terms of binomial coefficient. Both the values are same. What is the value? This value I should know. Start from here one second. C0 plus C1 plus C2 etc. up to Cn is how much? 2 bar n. Can you write this as C0 plus C2 plus C4 and so on plus C1 plus C3 plus C5 plus so on? Write all terms, then all even terms. Since I said these two are equal, that means this is exactly same as what? This particular part. So can I write this as 2 times C0 plus C2 plus C4 plus etc. Right, understand? This value remains the same. So I replace this by C0 plus C2 plus C4 and so on. So here also C0 plus C2 plus C4. Here also C0 plus C2 plus C4. So what I will get is twice. This 2 and 2 power n get cancel. What I will get? 2 power n minus 1. So the value for this is equal to how much? 2 power n minus 1. Two most important properties while doing problems in your binomial theorem, binomial series. One is sum of the binomial coefficient is 2 power n and the second is sum of even terms of binomial coefficient and sum of odd terms of binomial coefficient both are equal to 2 power n minus 1. Okay. So that property we need to solve your solutions. Okay. Just note it down. Then we will go for your infinite series and maybe introduction to exponential part. Next one, just to mention, binomial theorem for rational index. It is an infinite series. Binomial theorem for rational index. So usually we used to think of expansion of a plus b the whole square, a plus b the whole power 5, something like a plus b the whole power natural number. Now you have the expansion of the form 1 plus x the whole power n, but n is rational. Q is a set of rational numbers. How to do the expansion? So remember, my power is 1 by 2. 1 plus x the whole power 1 by 2. 1 plus x the whole power minus 1 by 2. 1 plus x the whole power minus 3 by 2. Once if we have such type of expansion, it is possible and your expansion is always in the form of, carefully observe, it should be always in the form of 1 plus x. Here the number is always 1 and you may have anything here x. Power is any rational number, okay, then that expansion is 1 plus nx plus n into n minus 1 by 1 into 2 into x squared. We won't write more terms and so on. It goes up to how many terms? Infinite number of terms provided. This is the symbol we use. Anyone knows? Called as mod x. Mod x value is less than 1. Means my x value lies between only minus 1 and plus 1. That is, x is sufficiently small, then only this binomial theorem for rational index is applicable. That's why I didn't write the other term. I said x is small. When x is small, x cube will be a smaller quantity. X power 4 will be a smaller quantity. When you have a smaller quantity, no need to write the term. So if you write the first 3 terms, but everything is equal to approximation. So we call it as approximations in binomial theorem. It is not exactly equal like your previous part. It is approximately equal to this. Most important criteria is x is sufficiently small. X value should be between minus 1 and plus 1. Suppose if you are asked to expand, see here, if you want to expand this, it is not 2x plus 3 the whole cube. What is the expansion of this? Or the question may be, identify the validity of x. Validity of x means what is the range of x? Here I said the range of x is between minus 1 and plus 1. Okay, listen, I won't expand. Even if I expand, I will write only first 2 terms. And speciality and easy one here is, my first term is always equal to 1. The second term is n into x. But first you write this as, I should take this 3 out because what is my expansion? Expansion should be in the form of 1 plus x. Am I clear? So I should take 3 out, then I will write 1 plus 2x by 3, the full cube. I have taken 3 out. Whether it is visible or not, I won't say. If I take 3 out, then I can write this as 3 into 1 plus 2x by 3, the whole cube. 3 cube, I will write 1 by 27. This part, can I bring it in numerator? 1 plus 2x by 3, the whole part, minus 3. Is it of this form? I said n is rational, any number. Now, if I expand, my answer will be, I will write only 2 terms. First term is 1 plus, what is my n? Minus 3 into 2x by 3, and it goes on up to infinity. My expansion is over. No need to write. That's a speciality and easy one in this part is, we won't write even the second term or third term. First term, maximum second term, and we will leave it. Now, when this expansion is valid, that is my question. I didn't want the expansion. The expansion is valid provided this value should be less than 1. I said here x, mod x should be less than 1. That means modulus of 2x by 3 should be less than 1. That means modulus of x should be less than what? 3 by 2. That means x lies between minus 3 by 2 to plus 3 by 2. Even in the optional sometime, if you have expansion part is not required, the validity of the expansion when you have a binomial theorem for infinite series is given. That one you have to do. So no need to go for the higher terms because as x is smaller quantity, higher powers of x is very small. We will remove and we will use the term as what? Approximation. We will use the term as approximation. Okay. Just make a note of this at least one, so that one more approximation problem we will do. So remember, that's a binomial theorem for rational index. The condition is very important, provided this condition is true. mod x should be less than 1, that is x should be between -1 and +1, then only the particular condition is true. One MCQ level problem. If x is large, cube root of x cube plus 6 minus cube root of x cube plus 3 is approximately equal to one answer is 1 by x, second option is 1 by x square, third is 1 by 3x square, and fourth one is 1 by 2x. So when you do the expansion, and obviously you can see cube root whole power 1 by 3, n is the rational index, and here also whole power 1 by 3. Just see the condition what I have given. X is large. That is applicable for what value for x? Smaller value for x. So when x is large, your 1 by x will be small. That's why you see all the four options, your x is not in the numerator. X is in the denominator. Try to understand the basic. Suppose if I give here x is small, my answer will come in terms of x numerator. Since x is larger quantity, that's why 1 by x, 1 by x square, 1 by x square, 1 by x is smaller. Then only I can think of this application. And the problem is very simple because in between you have a minus and both having the same power also. So two lines we will write x cube plus 6 the whole power 1 by 3 and x cube plus 3 the whole power 1 by 3. Right? Just modify the cube root as this. Now whenever you do this, my expansion should be in the form 1 plus x. So what I should do? I have to take your x cube outside. Remember? So the previous problem, that's why I didn't repeat of this. Here what I have done? I have taken 3 out. So because your x is here only, x is not in the denominator. So but here my x is here. So if I take x out, x is a larger quantity. If I take x out, then here it becomes what? 1. Then here it becomes 6 by x cube. Since x is large, 6 by x cube is small. Then I can think of the expansion. It's not that for any expansion, I think I can go with that. First condition, it should be in the form of 1 plus. So if I take x cube out, it is 1 plus 6 by x cube, the whole power 1 by 3, minus if I take here also x cube out, symmetrical, the whole power 1 by 3. Now this will be x into 1 plus 6 by x cube, the whole power 1 by 3. Here also x into 1 plus 3 by x cube, the whole power 1 by 3. Anyone have the answer?
1 by x square.
1 by x square. Now expand. Only two terms. Don't write more number of terms. X into first term is 1 n into x dot dot dot. Don't write any other term. Here x into first term 1 n into x dot dot dot. Higher powers don't write. Now you just observe this x and this minus x get cancel. X into this becomes x square. 6 by 3 means 2. So what I will get? 2 by x square. And I am removing all these terms, so I should use the word approximately. It is not exactly equal, it is approximately. Here once again, x and x cube will cancel. What I will get is minus 1 by x square. 2 by x square minus 1 by x square. My answer is 1 by x square. The option is there. And it is not equal to, it is approximately equal to 1 by x square, because I removed all the higher powers of x. Only the first term I stopped. Since x is large, 1 by x cube is small. So that is the answer. So MCQ level in one of, I think, Olympiad exam, it was that the previous, the value of not equal to, approximately equal to. So you have to get the solution. So binomial theorem for natural number, you can expand provided the power is a natural number. Not necessarily it should be 1 plus. But when you think of your binomial theorem for rational index, it should be always in the form of 1 plus x. Then only you can do the expansion. Okay. This one question. Maybe that last part of the discussion, we'll go with two important series. One is exponential, the other one is logarithmic series. Okay. The binomial theorem, binomial series, exponential, logarithm, all these are infinite series. Okay. I will give the formula, we will have the application. Okay, how we are supposed to use that exponential and logarithmic series while solving the problem. Okay, exponential, I think hope you know. We have the term called e. Anyone knows logarithms? Logarithms? Any one of you? Yeah. No one. Okay. We have a relation between the laws of exponents as well as logarithms. Okay, we have I'm saying the relation because once if I say, then I will write the series expansion. Okay, so we used to write pi squared equal to 25. Exponents, whatever you have studied in lower classes, the same thing you can express as a logarithm. As a logarithm means I will write log 25 to the base 5 equal to 2. In your exponents, very simple one. If you remember this conversion is possible. Then you will say this is the base, this is the power, this is the answer, resultant. The same base will come when you write as a logarithm. I use the term implies and implied. That is exponential to logarithm you can do. From logarithm to exponential also you can do. So pi squared equal to 25 you can write as log of this number to the base 5. The answer will be 2. The simple thing is, whenever you do the exponential part, my answer is always positive. Exponential part, my answer is always positive. Even if I say 5 power minus 2, can I write this as, am I right? So 1 by 5 squared is a positive. I didn't want the value. I will need the value whether it is plus or minus. So exponential part is always positive. And remember, logarithm is defined only for a positive number. Logarithm is defined only for a positive number, not for a negative number. And this, we call it as a base for the logarithm. So in general, if I write log x to the base a is y is true or is possible provided My x value should be definitely greater than 0. This x is nothing but this 25. And this is my base. This a is positive, but a cannot be equal to 1. Can anyone say why? If I take the base as 1 by any number will be 1. That's why when you write the base in logarithm, it should be a positive number, greater than 0. But it cannot take the value as 1. But the answer, whatever you are going to get, that belongs to R. That belongs to R. So the same thing I can write as exponential as a power y equal to x. See the conversion? Once if you know, I can write the series now. A power y equal to x is same as log x to the base a equal to y. What I said here, x is positive, so my exponential value is always positive. And what I said base should be positive but not equal to 1. But this power may be positive or negative, even 0. Even if I put 0, anything power 0, my answer will be 1. Are you able to get? So the conversion from exponential to logarithm. This we call it as an exponential part. This we call it as a logarithm part. So when you define your logarithm, if I define log x to the base a as y, only if x should be positive, a should be positive, but a should not be equal to 1, but y belongs to R. And since I use the term as E, logarithms, we have two types. One we call it as a natural logarithm, one we call it as a common logarithm. Okay, logarithm, we have a natural logarithm, the other one is common logarithm. I think if you have your record notebook, physics or chemistry or something, at the back side, you will have some tabular column values. Whether you have noticed it or not, at least in physics record notebook or chemistry record notebook, if you see, back side you will have a logarithmic values. Those values are to the base as 10. If I write log of any number to the base 10, we call that as a common logarithm. If I write any logarithm to the base e, we call it as natural logarithm. Morning, principal sir said any problem you can solve using one topic is calculus. So calculus, if I define anywhere logarithm, no need to write the base as e. It's by default the base is always e. Even if not, I should modify the base as e, then only I can solve the problem. So calculus is such a powerful tool. Any problem, even whatever problem we applied is the previous one, that approximation. If you apply calculus, second line will be your answer. If you differentiate something you do, you will have the answer. So the calculus, the total part will be based on this, and it has a value. Approximate, it is an irrational number. So E value is approximately 2.71. Approximately, I said. It's an irrational, I said. So approximately what value? 2.71. So now, what I started here? E power x. That E value is nothing but this 2.71. So now you know what is exponential 2. Logarithm, 2 types, common logarithm, natural. You may ask, sir, if base is 2, if base is 3, we won't have any specific name. Only you have the possibility with the number 10 and number e. Otherwise, you simply call it as a logarithm and you try to solve. That's all. Okay. Now, two important series. One is exponential. The other one is logarithm. I'm going to solve some two problems based on this and this. Only the series part you take. We will simplify algebraically and finally we will see this answer you are getting. Series is given by, before writing the series, you know the symbol. Summation, isn't it? Summation means sum up. Suppose if we want to find the product like this, isn't it? We used to write this as 8 factorial. Okay, summation means a plus b plus a plus b. Okay, like that. So when you want to multiply the first consecutive natural numbers, consecutive. Hope you recollect when we do the combination calculation. What I said in the denominator, write 4 numbers starting with 1, 1 into 2 into 3 into 4. Actually, there is a factorial. So we call this as what? 8 factorial means you multiply from 1 to 8. 10 factorial means start from 1 and multiply up to 10. But in a short form, we will write as a factorial. Okay? And 1 factorial means the answer is 1. 2 factorial means 1 into 2. And the speciality is 0 factorial is 1. 0 factorial is also 1. How in the sense? Permutation when you discuss that time, definitely they will say the justification. You won't have a proof for this. They can justify the 0 factorial value can be taken as 1. So this value. Now factorial means what? The product of consecutive natural numbers. Suppose if I have 7 factorial, can I write this as 6 factorial into 7? Alright. 10 factorial can be written as 8 factorial into 9 into 10. Able to get. So can I generalize the term? N factorial can be written as n into n minus 1 factorial. N factorial can be written as n into n minus 1 factorial. Just observe, apply this. 7 factorial is 7 into 7 minus 1 factorial. That is 6. 6 factorial into 7. So because in exponential series, the term factorial concept will come. In logarithmic series, factorial will not come. After simplification only, you will come the term. And logarithmic series means it is not log x. Okay? Exponential series means it is e power x. Logarithmic series means log of 1 plus x. What is my base? Base is e, natural logarithm. Okay, this series is somewhat simple. That is, the expansion is x minus x squared by 2 plus x cubed by 3. You say the next one? X power 4 by 4. Alternative in sign, and the power goes like this, starting with x squared by 2, x cubed by 3, and it goes on up to infinity. Okay. Now for problem purpose, what I need is the value of log 2. The value of log 2. So in mathematics, the log 2 plays the major role in solving problems. So you should know the series. Remember, this has an infinite series. Put x equal to 1. If I put x equal to 1, what I will get? 1 minus 1 by 2 plus 1 by 3 minus 1 by 4, and it goes on up to infinity. So my problems are based on this. That's why I have given this formula, and immediately I have substituted x as 1 so that I am getting the value for log 2. Now, exponential series. In exponential series, we will get even factorial terms. And the series is all positive terms. How it starts means, it starts with 1 by 0 factorial, x by 1 factorial, x squared by 2 factorial, and it goes on up to infinity. So remember only these two. Whatever expansion you need, you can replace and you will get. So e power x will have the expansion 1 by 0 factorial, x by 1 factorial. Factorial is important. Even if you are not writing factorial, answer is 1. 2 factorial is 2. But afterwards, definitely the factorial notation is must, because 3 factorial value. 3 factorial value is 6. So factorial part is there. So 1 by 0 factorial, x by 1 factorial, x squared by 2 factorial, and it goes on up to infinity. Now, something I said the value for e. 2.7. Shall we justify approximately? by put x equal to 1. If I put x as 1, this is 1 by 0 factorial, x as 1, 1 by 1 factorial, this is 1 by 2 factorial, and it goes on. Remember, it is an infinite series. How many terms are there? And remember, the terms are not in AP, not in GP. Remember, the terms are not in AP, not in GP. First term is 1, next term is 1, next term is 1 by 2, next term is 1 by 3 factorial, and it goes on. But these are the terms, starting with the first today's class sequence, the list of numbers. Okay. Now, what is this value? This value is 1. 0 factorial is 1. So this value is 1. 1 factorial is 1. So this is also 1. You got the answer too? Now, afterwards, this is 1 by 2. Just see the numbers. I won't say, I will write. Next number will be 1 by 6. 3 factorial. Next number? 1 by 24. See that your denominator value is in increases, and every time you are dividing 1 by that number. That means is the numbers are smaller like that, isn't it? If I take 1 by 2, it should be 0.5. If I take 1 by 6, it should be 0.0 something. 1 by 24 will be 0.00 something. I am just writing. So everything will come after decimal places so many zeros. And when you sum it up, definitely it will not come to approximately also 1. So this is already 1. Here 1, 2. Afterwards, if you add up to infinite number of terms, it is approximately equal to 2.71, and it goes on. It is an irrational number. We know what I mean by that. Non-terminating, non-recurring. It will go on. So for the easy purpose, only 2 decimal places we will remember. E value is nothing but 2.7. Even if you remember, that's well and good. So this is the thing we said for your natural logarithm. Natural logarithm. Now with this 2, e power x and this, we will do some problems where you need the basic algebraic concept of simplification. That's all. Okay. Shall we do at least one?
Yes.
Yeah. We'll see how I'm going to simplify this. Remember this part. Okay. Find the value of find the value of 1 by 1 into 2, it is not decimal, into 1 by 1 into 2 plus 1 by 3 into 4 plus 1 by 5 into 6 and so on. We have to find the value. Now you just observe, once if we have the problem of this nature, we should identify whether it is in progressions or binomial or logarithm or exponential. So many things are there. And the hint for the problem is, since there is no factorial at all, maybe it's a logarithmic series. No factorial, yeah. You are giving the total value. Yeah. What's it? 0.71. How many terms you have calculated in summation? Is it in some progression where you apply the formula? It goes on up to, maybe you have calculated 1 by 2 plus 1 by 12 plus something like that?
Sir, it's log 2.
Answer is?
Natural log 2.
Answer for the problem is log 2. Remember, we are discussing the problem on logarithmic and exponential series. How is that it is log 2? That's why I said, algebraically you just think of how we are going to rewrite the terms. That's all. You will get this particular part. Can I write this as, the answer is 1 by 2. Can I write this as 1 by 1 minus 1 by 2? You just justify this and this is same. And obviously 1 by 3 into 4 can be written as 1 by 3 minus 1 by 4. This is what I can say, the logic we have to think. So 1 by 3 minus 1 by 4 will be 4 minus 3 by 3 into 4. It is coming. The same way this will be 1 by 5 minus 1 by 6. Goes on up to infinity. Can I remove the parenthesis?
Yes.
If I remove the parenthesis, whether you are getting this part? isn't it? That is exactly same as what? Look. So this expansion of the series, remember infinite series. Once if we have an infinite series, think of either binomial or exponential or logarithm. These three. Okay. Geometric progression won't come here because it is not in GP. The terms are not in GP. It is not in AP. So only you have to think of the last set of three series, either binomial or logarithm or exponential. Okay. One more. Let's see. 1 by 1 into 2 into 3. These are somewhat standard problems in algebra and exponential and logarithmic series. 1 by 3 into 4 into 5. 5 into 6 into 7. It goes on up to infinity. Okay. The hint is, once again, the problem is in terms of logarithms. Algebraically, you think. Don't think of anything now. Okay, not this or this. How to modify the numbers? Algebraic way. What I said is algebraic way. How it is possible to? We have done this. This is one way of grouping the terms. Okay. Can you remember when you apply this particular logic? It should be true for all the terms. Then only I can apply. If only for this term it is applicable, this term is not applicable, I cannot do. This set of application is true for each and every term. It is applicable. So we have, can I write this as, I bring you to the previous problem. Can I write this as 1 by 1 into 2 minus 1 by 2 into 3, it is into, okay. Justify. LCM is 6. Alright. Then it will be 6 minus 2. What I will get? 4 by 1 into 2 into 3. Am I right? So 1 by 1 into 2. Here 1 by 2 into 3. So if I write, I am having one number. 6 here minus 2. 4 by 1 into 2 into 3. But you are not having the number 4. So what I should do?
1 by 2.
Yeah.
Get divided by 4.
Divided by 4. Or suppose if I write here 1 into 2 into 3. By taking LCM as 6. So what I will get here? Here 3. Here minus 1. 3 minus 1. 2. Since extra 2 is there, can I write 1 by 2 here? This answer and this answer remains the same. Is it applicable for the next if you write in the same pattern?
Yes.
Check. Can I write this as 1 by 3 into 4 minus 1 by 3 into 4 into 5? Correct? So once again, if I simplify, 3 into 4 into 5 you have taken. So what I will get here? Here the LCM will be equal to 5. Here I will have 3. So extra number will be 1 by 2. Just check it. In the process, if it is correct, then we will proceed. Or any modification if you want, we can do. Minus 2. Yeah. Should bring it to that particular form. First, we'll check it. 1, 2, 3, 3, 4, 5, 6, 7. Here. This one. Shall we write? Just check it. 2 into 3, and I write this as 2, 3, 3, 4, and 4, 5. If I write by taking LCM as 20, here 20, here 12, 8, 8 divided by 2, it should not maybe somewhere. One minute, I'll just check it. It's again.
First, I will take. Somewhere number I have taken off. I'll just find out and I'll just pass it. You'll just leave that part. Okay. I'll just check it once. Anyway, just we'll see once. This problem is just one problem. The value of 1 by 2 factorial plus 1 by 4 factorial, 1 by 6 factorial, etc. up to infinity. Yeah. Okay. We'll see this once. Find the value. As I said, once if we have factorial part, answer should come in terms of exponential. Okay, factorial is that. Terms are not continuous. 0 factorial, 1 factorial, 2 factorial, 3 factorial, all the terms should be there. Here the terms are missing. 2, 4, 6 with factorials are there. So now from here you start. Okay. Here you put your x value as 1. If you put x as 1, what I will get? 1 by 0 factorial, 1 by 1 factorial, 1 by 2 factorial, etc. up to infinity. Okay. You just see some criteria that in the same result, you put x equal to minus 1. If I put x as minus 1, what I will get is e power minus 1. What I will get here? 1 by 0 factorial minus 1 by 1 factorial plus 1 by 2 factorial. It goes on automatic sign. Somewhere I need this. Now what you do is just you add. So when you add this term 1 by 1 factorial, 1 by 3 factorial, 1 by 5 factorial, those terms get cancelled. Am I right? So what you will get? 1 by 0 factorial 2 times, 1 by 2 factorial 2 times, 1 by 4 factorial 2 times, because I have 2, 4, 6 factorial like that. So when I add this and this, I will get 2 times 1 by 0 factorial plus 1 by 2 factorial plus 1 by 4 factorial, etc. up to infinity. You have only this part. Am I right? Here. Question. Now what I will do is, this 2, you bring it to the denominator first, which is equal to 1 by 0 factorial plus 1 by 2 factorial plus 1 by 4 factorial, etc. up to infinity. Only this part I need. This is my question. Find the value. So we bring this to this side. So what I will get? E plus e power minus 1 by 2 minus 1 by 0 factorial is 1. Bring this side. Is it my question? LHS. This particular part. Now simplify. If I simplify this, e power minus 1 can be written as, can I write 1 by e? By 2 minus 1. Because final answer should come in terms of a perfect answer. That's why I am simplifying. Take LCM. So what I will get? E square plus 1 by e by 2. That means by 2e minus 1. Further take LCM. E square plus 1 minus 2e by 2e. If you see this, is it a perfect square? So this is e minus 1 there, whole square by 2e. So the answer for this problem is e minus 1 the whole square divided by 2e.
That is the solution. So only with one formula, only one e bar x. The other one is log 1 plus x. Only with this, I think all the problems in logarithmic and exponential series are simplified. That is the question. Okay. Suppose if I give one question the same way, 1 by 1 factorial, 1 by 3 factorial, 1 by 5 factorial, and have the value 1 by 1 factorial plus 1 by 3 factorial plus 1 by 5 factorial, etc. up to infinity. In most of the steps are there as it is. So the same steps. Since I need 1 by 1 factorial, 1 by 3 factorial, that means I need this part. So what I should do? Here we have done addition. Now you subtract. If you subtract, this term get cancelled. What I will get is 1 by 1 factorial, 1 by 3 factorial, 1 by 5 factorial, everything will get how many times? Twice. So this will be 2 times of I will get. That is e minus e power minus 1 equal to 2 times of this. So 2 will come down. I will remove this. So 1 by 1 factorial plus etc. is this. For the simplification, I can write this as e minus 1 by 2. E squared minus 1 by 2e will be 1 by 1 factorial plus 1 by 3 factorial plus etc. to infinity. So exponential and logarithmic series is not a difficult one. Only thing you just remember log 1 plus x expansion and e power x expansion. Once if you know this e power x and log 1 plus x expansion, any problem in logarithm as well as in your exponential series, anything only with this formula, I think that will be sufficient to be given required answer. Okay. Partial fractions,
So before I tell anything else, I will start off with somewhat of a backstory. So back in my place, whenever I try to learn or practice these topics like the logs and GM, AM, GM relations, they were very problematic to me, and I guess for most of all of you. But the main thing that I found here was that Sir's miraculous teaching that made me understand all these topics very well, and I hope that most of you, all of us, have gained them very easily. So for that, I thank Sir, and so thanks a lot.